Hello, good morning all. So we were discussing last class regarding the types of the buses. So now we are moving on to the bus admittance matrix. How can we form a bus admittance matrix? This is very important topic and we need it for all our further calculations. Okay, that is we have to do our load flow analysis and our fault analysis. For fault analysis we will follow this bus impedance matrix, but the load flow analysis we are using Y bus matrix because of its certain advantages it has got. So let's move on to a 3 bus system. So for this 3 bus system, we know that the I1, I2 and I3 are the currents coming inside to the our buses 1, 2 and 3. And we have line admittance, that is from bus 1 to 2 there is a line, and the line admittance value I can notate it as Y12 or Y21, and the current flowing through it can be I12 or I21. Similarly, I have another line uh, connecting bus 2 and 3. So I can name it as Y23 or Y32. Both the magnitudes will be equal and the current flowing will be from I23. Similarly, while I am considering my third line, that is 1 and 3, the line admittance is Y13. Okay, so before doing our bus admittance matrix, we have to check in the question that whether it is given in R plus JX form. R plus JX form means impedance form, isn't it? Z is equal to R plus Jx. But here what we want is we want admittance. Okay, so if it is, what is G minus JB, that is Y, 1 by Z is equal to Y, that is G plus JB or G minus JB. Okay, so if we are having a minus term to the imaginary coefficient, then we can say it is admittance given. So first we have to check whether the impedance or admittance is given. That I will make it clear while doing the problem. Okay, so we are considering a 3 bus system and we are going to apply the rule. We are applying Kirchhoff's current law. That is, the current entering the junction is equal to the current leaving the junction. So refer to the second slide, we have I1 is the current entering and we are assuming that I11, I12 and I13 are the currents leaving. So just I am giving the equation, that is I1 is equal to, in terms of admittance, V is equal to I into Z, isn't it? V is equal to I into Z, or I is equal to V by Z. But 1 by Z is Y, you know. So Vy, I can say I is equal to V into Y. So I11 is the shunt admittance or shunt capacitance connector. Okay, that is connected only to the bus 1 and the ground, or that is connected in between the bus 1 and the ground. That's why I am telling it I11. Okay, so I12 is the current flowing from bus 1 and 2, and I13 is the current flowing from bus 1 and 3. So I am employing this. So I11 equation is V1 into Y11, and I12 is there the current is flowing from 1 to 2. That means the potential of first bus is highest, or bus 1 is higher. So V1 minus V2 into Y12 plus V1 minus V3 into Y13. And what we are doing is we are just expanding the terms and rearranging with reference to V1, V2 and V3. So I am grouping all the things having variable V1, V2 and V3. So I will get I1 is equal to V1 Y11 plus V2 Y12 plus V3 Y13. Okay, so here what I have made a small mistake is I11, that Y11 Y12 in the initial stage it is small letter Y11 Y12 Y13. I repeat, please take that the main equation, that is I1 is equal to I11 plus I12 plus I13, no? So that this main thing, this Y11, Y12, Y13 in the equations they are small letter Y11, Y12 and Y13. Whereas in the main equation I1 is equal to V1 Y11, that is a capital letter. Okay, so we have the difference. Please understand the difference. Okay, all other except the last equation, I1 is equal to V1 Y11 plus V2 Y12 plus V3 Y13. There all the admittant terms are capital letters of Y, and all others Y's are small letters, that is line admittance value we are taking it as small letters. Okay, then we have to apply this equation. So again, we are applying Kirchhoff's current law to our bus 2. What happens when Kirchhoff's current law is applied to bus 2? You know, the current coming inside is I2. That will be equal to I21, I22 and I23. I told you, no, these Y21, Y22, Y23 are those corresponding to the line admittance. We notate it with a small letter Y, okay? The small letter Y and capital letter Y in the general equation are different, okay? You please keep in mind the capital letter Y in the general equation and the equation for KCL for node 2, those y's are different, okay? Just we are forming in the general equation like y21, y22, y23. That is a general equation, okay? So y21 will be equal to minus of small letter y21, okay? So similarly, we are applying it for Kirchhoff's current law for node 3. We will get like I3 is equal to I31 plus I32 plus I33, and we will get the equation as minus V1 Y31 minus V2 Y32 plus V3 into Y31 plus Y32 plus Y33. Okay, so if we are writing in the general form, we can write it as I3 is equal to V1 Y31. Look, that Y31, capital Y31 should be equal to minus of Y31. Okay, so in the problem, while we are solving for the problem, if in the question it is given y13 value is given, you should always remember y13 is equal to y31. Okay, both values will be same. If the value is given, while substituting in our y bus matrix, you should write minus of y31. Similarly, Y32. In order to generalize, I can say if we are while forming our Y bus matrix for non-diagonal elements, we have to take the minus of actual admittance to fill in the bus admittance matrix. And for diagonal elements, we have to take the sum of all the admittances connected to that particular bus. I repeat, while finding out our bus admittance matrix, we have diagonal and non-diagonal elements. First, we have to check whether we were given admittance value or impedance value. If it is impedance value, example R plus JX form it is given, example plus J3 or plus 0.01 plus J5, like that it is given, then it is given in the impedance form. At that time, we have to convert it into admittance form. That is, we have to take 1 by, or we have to take the inverse of the given data. So that will be y12 or y23 or something. Then to fill in the admittance matrix, we have to take that minus of that y12. For all the non-diagonal elements, we have to take minus of the line admittance. And for diagonal elements, we have to sum up all the admittances connected to that particular bus or that particular node. It is very easy, and just I will show you one more example. Okay. So in this slide, what we are doing is we are summarizing it. So our 3 bus matrix can be written in the form of I1, I2, I3. That is bus. The matrix I is equal to Y bus matrix into V bus matrix. Okay, I is equal to Y matrix into V matrix. Okay, or if I am writing it as equation, then I can say current in the ith bus should be equal to sigma j is equal to 1 to n Yij Vj. Okay, where I is the ith bus we are considering and j is the other buses the ith bus is connected to. Okay, then we have, if I am having, what is the advantage of taking this Y bus matrix? Since this is a matrix and if no elements is connected between I and j, the value of Yij will be 0. Okay, if a matrix having 0 is there, the calculations become much easier. So let us consider an example. So I have given a 5 bus system. You should Note that it is 5 bus. 1, 2, 3, 4 and 5 are there, in which 1 and 3 one generator is connected, and 2, 4, 5 it is a load connected to it. So in order to find our Y bus matrix, since it is a 5 bus, the Y bus or admittance matrix of the order 5 row and 5 column, that is 5 by 5 matrix with 25 elements. And we can see that there is an element connected from 1 to 2, then 1 to 3 no element is connected, isn't it? So y13 will be 0. Then 1 to 4 no element is connected, so y14 is 0. No, for y14 we have connected an element, so y14 value is there. Then y15 also value is there, but y13 it is not directly connected, so the value of y13 is equal to 0. Okay, so if we are adding a element to 1 and 3, we can directly fill that matrix y13. Whereas if we are doing the same computation in admittance matrix, then we have to follow the algorithm. This is y1 first row minus fourth, here we are connecting y13, no? So first row minus third row, first column minus third column, then we have to note the last element, right? Z17 plus like that equations we have employed. Okay, but whereas in an admittance matrix it is easy to add a matrix or easy to add an element. If we are adding an element connected to y13, then we can just fill the admittance value there directly, whereas for y bus we have to find out y1. In order to connect y13, first we have to find assume it either as a new bus, then we have to reduce it, or y1 minus y3 we will get a new column, and then again we have to do the cross reduction. So that's why in normal studies we employ admittance matrix. So in an admittance matrix computations are much easy, and it is easy to add or remove an element. Okay, so in this question we have to find out the y bus. So check what is happening here. Here I haven't given any values, just to give you an example of the advantage of Y bus or admittance matrix. I am giving this. So Y11 one element will be there, Y12 is there, Y13 it is 0, Y14 Y15 is there. Similarly 21 2 is there, 2 3 is there, 2 4 is not connected. So 2 4 value is 0, 2 5 value is also 0. Similarly there is no connection between 1 and 3, so it is 0. Y32 is there, 33 is there, 34 is there, and there is no connection between 3 and 5, so 35 value is 0. Similarly y1 and 4, 1 4 is equal to 4 1, and then 0, then 3 and 4 are connected, 4 and 5 are connected. Similarly we are doing the same with the 5. 5 is connected to bus 1 and bus 4 only. Okay, 5 is connected to bus 1 and 4 only. So 2 and 3, 5 2 and 5 3 are 0. If we are forming a Y bus matrix, this will be the form. Okay, so it is easy to add or take away an element, and also you can notice that here this matrix is symmetrical. The upper trigonal element or um, upper triangle, the elements of the upper triangle is equal to that of the lower triangle. Okay, or it is symmetric with reference to the diagonal element axis. y11 y22 y33 y44 y55, all the values we are taking as positive values or diagonal elements gives the sum of the admittance connected to that corresponding node or bus. Okay, whereas non-diagonal elements, they are symmetric, and in order to take this we have to take the minus value of the line admittance. Okay, so then we have to go through, or we have to conclude what is an admittance matrix. In conclusion, the Y-bus matrix represents a non-admittance of each bus and it analyzes the topology. Topology means arrangement, the type of the arrangement, whether any element is present in between the buses or not. And the most important, Y-bus matrix is a symmetric matrix with the diagonal elements. We call it as driving point admittance or self-admittance of that particular bus, and the non-diagonal elements we call it as a transfer admittance or mutual admittance. Okay, and we have, because of these peculiarities, we are using IBUS metrics for our calculation for the following advantages. Very important question. What are the advantages of a IBUS matrix? That is the data preparation, representation, adding and removing of elements, modification, everything is very easy for a bus admittance matrix. Okay. And it requires only very less memory because the upper triangular elements is equal and same as that of the lower triangular elements. So we need only half the memory space to save this values in a bus admittance matrix. And also this matrix is a sparse matrix, it has 0 elements. So in order to solve the problems, if we have to study what is the relation between bus 3 and 5, the voltage and currents flowing in between, just we have to consider that third row or the row and column corresponding to 3 and 5. No other things, we no need to take it. So the computations and all the calculations become easy when we are using an admittance matrix. So I am winding up my section on admittance matrix. These two links I have given, I am giving this. These are the first part of Newton-Raphson and Gauss-Seidel problems which we are going to discuss. I am giving the link so that from that link you can understand how can we form a Y-bus. Okay, more problems and the previous university questions will be uploaded after that. First we will cover all the portions, then after that we will be going making a question bank and going through all the questions that were asked for previous university examinations. Okay, so I am posting this in our YouTube, in my YouTube. It is not that a professional channel, but my YouTube subscription, I will post it. And if you want to get all those notifications which we are adding, then just subscribe. Okay, thank you. Happy learning.